Let's start. Morning, everyone. Today we are going to see about subquery. Prior to this, I just gave some small explanation about subquery. This was the example. I said select employee number, employee name from table EMP. So this will extract two columns. Okay, so if I want to make this as one table, what I'll do is I'll just place this inside bracket. Okay, I place it inside bracket. That becomes a table. Now I can use select statement. Select, I can say employee number column from, that becomes your table. This is the table, inner table. So this query will extract two columns, employee number, employee name, whereas the outer query is going to extract only employee number column. Okay, can I use department number here? No, I cannot. I cannot use it. Why? Because we are extracting only two columns. If I would have given here comma department number, then it would have been possible to extract data from the table which has got three columns. Actually, we have got 8 columns. From that 8 columns, I'm filtering and extracting only 3 columns. So out of 8, if you have 3 axes, 5 is gone, we have 3. So from this 3 only, I can extract whatever columns I want. Okay. So this is the inner query that will be executed first. It creates a table. This table will be called as virtual table. Okay. And this virtual table, I can refer it outside. Okay. Now, can I give a name to this table? The entire table which is there, can I give a name to it? The answer is yes. So I'll just say it as employee. Then what I should do is I should say select employee, select star from, this is your employee table. Let us check this. So I'll copy the query, try to execute it. And see, it is extracted. The inner query has extracted three columns. External query has extracted only one column. So this becomes a table. So if I want to be specific about table name, I can give it like this also. Here I can use employee dot. Employee dot. What is employee? Employee is a table that has been created. That is actually a virtual table. Okay. So I can give it like this. Same, output is same. But here we are referring to the table name dot column name. So what is the table name? Employee is the table name. Inner table name, we give it as EMP. This is the actual source. And this is the virtual table that we have created. So if you want to hide the actual name from the user, we can do it with the help of table alias. Alternate name to table. So the end user will never know that he is referring to EMP table actually. Okay, he will just know that he has got only 3 columns in the table employee, which is not existing. It's a virtual table. Okay. All right. So that is what I did. Same query, but only thing is like we referred to the table name along with column here, employee. Okay. Now let us check. A little bit complicated. This is called as your simple subquery. You can go up to 255 sub levels. How many levels do we have here? Only one level. In this way, we can go 255 sub levels of queries. Okay. It is said in documentation. No one has tested that, but you can go up to 255. If you have only 2 or 3 subqueries, it will be like repetition of same query. Okay. So very rarely you will be having sub levels as 3 or 4 maximum, not more than that. If you give, then it is like repetition of same query. Okay, but you can go up to 255 subquery levels. Let us check an example where I want to display employees working in 10. Employees working in 10. So I can just say select department number from EMP. Okay, this is the query. Now I said to display employees in 10. This is perfect, no problem at all. So let me copy this. Okay. I just said select department number from EMP. I got this. 10 is displayed. Okay. Now I said only department number 10. So for the same query, I can use department number is equals to 10. It should be with where clause, where. So only 10 I'll get if I execute this. Okay. Because it is known, we know that department 10 is existing, we are able to extract it. Now I'm adding up a subquery here. I want to find out what is the department of Smith. What is the department of Smith? Now check this. I'll say select department number from EMP where E name is equal to Smith. What it will return? Smith's department number. Now the query is display all employees who are working with Smith. This query is going to give me in which department Smith is working. But I want to find out how many of them are working. Okay, how many means the list of people who are working with Smith. So it's purely dynamic. Okay, so let me just give you. This is simple with a condition. So here we gave the query as select department number from PBEMP where department number is equals to 10. This is direct access, but this query is extracting department number of Smith. So if I want to get all employees working with Smith, this should become your subquery. Okay. Whatever I gave you, this part will become subquery. I'm just repeating this and copy, paste it, and I'll give this in brackets. So the inner query is returning what department number. I want to get all employees. I'll say select star from EMP where department number is equal to the subquery. This is your subquery. Okay, and what happens? First, it will find out Smith's department. Then what it does? It will find out all employees working in that department where Smith is working. Okay, so that is how the query works. Let us check this. So I should get all employees working with Smith. Smith is working in 20. So all employees from 20 should appear. So these are all employees in 20, 20, 20, so on. So on. Okay. So that is how we can give query within a query, subquery. Okay. Is it clear? Okay. Next is I would like to go for something which is called as joins. Joins is used if you want to extract data from more than one table. Okay. So extracting data from multiple tables is possible with the help of joins. Joins number one, there are 4 types of joins: equi, number 2, non-equi. Okay, outer, and number 4 is self join. Okay, and we have got equation for join. So join is equal to number of tables minus 1. Okay, that means if I want to go for join, if I have 5 tables minus 1, output is what? 4. I need 4 joins. If there are 2 tables, table 1, table 2, how many joins are required? 1 join, like that. 10 tables, 9 joins. 100 table, 99 joins, like that. Okay. So this join can be equi, non-equi, outer, or self, depending on the data which is provided to you. Okay. So let's go with analyzing the data first. So I'm going to prompt here. I would say describe EMP table and describe department table. That means we are using how many, describe EMP table and describe DEP table, DEP table. Okay. So do you have any common columns in between them? Check. Department. That means if you have common columns, then we can go with a join called as equi-join. Okay, so here I'll give about equi-join. Join between tables with the help of common columns is called equi-join. Okay, so let us take an example. So I'll say select from first table, I'm extracting EMP table, I'm extracting employee number. From same EMP table, I'm extracting employee name. From EMP table, let's say salary. From EMP table, job. From EMP table, hire date. Okay, and from DPT table, I'm extracting department name. And same from DPT table, I'm extracting location from table EMP and DPT. Okay, so that is how you can end it here. If I'm ending it here, there is no join. I did not use join. This will result me in product which is called as Cartesian product. What is Cartesian product is? Number of columns, number of rows in table 1 multiplied by number of rows in table 2. Table 2. Okay, let us say in table 1 we have got 14 rows. 14 employee information we have. In your department table we have got 10, 20, 30, 40, 4. Okay, so what is the output of this? 16, 5, 50, 56, right? 56 is the output of it. Let us check. I should get Cartesian product. 56 records should be displayed because I'm not giving a perfect join. If it is not a perfect join, it is giving Cartesian product. Okay, let us see this. Paste it. Enter. So 14 into 4, 56. What is happening? Let us check. Going on top here. See. Smith, Alien. It says New York. Department. Okay. Okay. Smith, Alien. Everyone. Total 14 records. They're showing New York only. See, till here. It is 14 records. All are working in accounts. Similarly, all are working in research. All are working in sales. So 14 for every record in your department table. We have 4 records. That's why I said table 1 multiplied by table 2. That is the output. And this is the total number of records that are displayed, which is wrong. So if you're not giving right join, it will result in Cartesian product, which is of no use. So for this reason, we use perfect join. So I'm just going to give the same query, but I'm going to give a condition here. Okay, here the condition would be, I'll say, where EMP dot department number should be equal to DPT dot department. This is called as equi-join, common columns. So if I'm running this, I'm going to get 14 records on. Okay, check. Here. Listed. Oh, that's your rejoin that should give you 4 records. So I'm able to get all the employees along with their department. But if I want to list of employees working in Dallas, I can add a condition here. select all the column names from EMPDPT, from EMPDPT, and give condition where department number is and I'll say department dot location is equal to Delas. So what am I doing? I'm filtering all the employees working in Delas. That is what it means. So you can see here, this is employees in Delas, so on. Okay. So Delas is which location? You see here. Select star from BPD. Check. Delas is located in Delas is research department. So all these employees who are displayed, they are in 20, department 20. Okay. This one, I'm adding up one more column here, comma, DPT dot department number. Okay. From table name, where condition. So I'll get even department number. See, all are in 2020. Okay, clear? So I want to display all employees who are working in the same department as that of Smith. I'll repeat the question. See, the question is given like this. Display all employees who are working in the same department as that of, let's say, Jones. First I should find out is Jones department name. Jones department name, Jones department number is what I have to find out. Okay. I'll say display all employees who are working in the same department as that of Jones. So first I should find out Jones department number. Now I'll say select. Okay, select, I'll say DPT dot department name from table EMP, where I'll say E name is equal to Jones. So this will give me what? Jones department name. But I should give a where condition because we have got two tables. Department name is coming from department table. So here I'll say include the table that is comma department DPT, DEPT. If I just leave it like this, it will give me Cartesian product. So to give it properly, I should add up the condition. And I'll say DPT dot department number is equal to EMP dot department. Or I'll say EMP dot department number is equal to DPT dot department. Okay, so join is being given. James data is going to be filtered, and I would be able to get Jones department. Okay, so let us execute this and see. It should show me only one record. Okay, which will show Jones department. So Jones department is research department. Okay, so Jones is working in research department. So I want to display all employees who are working in the same department as that of Jones. So this becomes your subquery. Okay, so I'll just say edit. Here I'll say this is subquery. Just placing that in bracket. That is your subquery. And main query should display what? All employees. So I'll say select star. Select star from table EMP. Okay. So this will display from EMP. So I'm including comma DEP2. Okay, now I'm giving condition where DEPT dot department name is equal to the subquery. Okay, now do we have equi-join given here? No. So the outer join, inside we have got equi-join. Outside we are having two tables. Inside we have two tables. Outside also we have got two tables. So this join what we gave here, this is for inner query. Same thing I'm repeating it outside also, and I'm giving the same condition. Why? Because I told you if you don't give a join, the result will be Cartesian product. So this join what we gave, it is for outer query. Because outer query is also referring to EMP and department. So whenever you're referring to two tables, we should give a join. Okay. So let us check this output. Okay, run this. So all employees working in research is being displayed. Okay. The question was display all employees who are working with Jones or display all employees who are working in the same department as that of Jones. That is how the query is given. This is called as equi-join. Okay. Equi-join. Let us see one example on non-equi-join. Okay. Equi-join, non. Oh, what happened? This is equal. Now let's go for non-equation. So before I go, I'll show you two tables. Describe EMP. Describe SAN grade. Any common columns? No. No common columns, no equi-join. Okay. But there is something which is relevant or related to these two tables. Let me show you first. I'll say select SAN from table EMP. This is the table EMP and I'm extracting only salary column. This is the output. Multiple salaries we are getting. I want to arrange it in order. You can use same EMP order by salary. Order by salary. That will show me in ascending order. I gave that in ascending so that you can understand the importance of this and salary. Select star from salary. If you consider here, if I say grade 1 are the employees whose salary is in between 700 and 1000. So if you see here, we have one person, 800, that comes in between this two range. He's a grade 1 employee. Random pick. Let's say I'm taking up 3000. 3000 comes under which range? 5th range. So anyone in between this two is called as grade 5 employee. Okay. If I take one more, let's go with 1500. Which grade employee? 1500. Third grade. So we have table. We have some data that is related to salary, but those columns are not common columns. So when there are no common columns, we cannot go for equi-join. We have to think about other way of approach by which we can extract it. That way is called as non-equi, means no common columns is non-equi. Okay. So let me give that point. Join established between table without any common column, but with relevant data is called non-equi-join. Compulsory questions will come from joins. So you should be good in joins. Practice a lot. Okay, let us see. I'll say select first column. From EMP, I'm extracting EMP dot ename. Name is extracted. Next, I want job, EMP dot job. Comma, I want employees department, EMP dot DEPTNO. Hire date, EMP dot hire date, HIRE, hire date. And then I want to have from department. We don't have department, we have sal grade. So I'll say sal grade dot grade from table EMP, comma sal grade. Where condition should be given. If you don't give, it is Cartesian product. Okay. Where I'll say EMP dot sal, and so employee salary should be between sal grade dot low sal and sal grade dot high sal. These are the two columns which are there in that. So I'm telling that if salary is in between this two range, then show me the grade of the employee along with name of or details of employee. Let us check the output of this. So in addition to all columns, we are included grade column. Okay. Grade 1, grade 2, grade 3, grade 4. So I want employees who are only grade 1 employees. Add up the condition here in the same. Okay, here same thing I'm repeating, and I'm giving one more additional condition. Okay, so here itself I'll filter it. Where I'll say sal grade dot grade is equal to 1, and that becomes your one more condition. Okay, that's a condition, not subquery. Okay, give it in brackets so that it can avoid the confusion. So salary should be between this as well as grade should be grade 1 employee. Okay, so the query is display all grade 1 employees. If that is the query, this is the answer for that. Let us check. Paste it. Run. All grade 1 employees will appear. This is called as non-equi join. So equi join, common columns, non-equi join, non-common columns. Okay. Next, number 3, outer join. Okay, so here we go. It is based on master detailed relationship. It is based on master detailed relationship. Now I'm referring to two tables. One is EMP table, another is DEP table. Now you should tell me which one is master and which one is detailed. Just by saying that. EMP and DEP, which can be master, which can be employee is master. Okay. So this one I just gave M, it is master. And DPT is detailed, right? Now one question. When you join a company, will they hire employees directly and then create department? Or will they create department and then hire employees? Then department becomes master. This is wrong. Okay, so this is master and this is detail. Whoever comes first becomes master. Whoever comes next becomes detail. Like teacher, students. Students are detail of master. Okay. Now, let us check outer join. There is something special in department table. Let me show you. Select start from B. What is special? You should tell me. Select ename, comma, department number from EMP order by department. Now, see that and tell me what is special in department table. There is no 40. That means what? Department name, I told department is master. So company started, they divided a room into 4, 10, 20, 30, 40. They recruited employees in 10, 20, 30, but no one in 40. Okay, no one in 40. So if I'm going for equi-join, I'll get information of 10, 20, 30. I will not get about 40. Why? Because equi will check for equal values. But in employee table, we don't have anyone working in Boston. In the operations department, no one, they have not selected anyone. Possible? Yes, possible. Department is there, but there are no employees in it. So in this case, equi-join will never give me any information about master. That is Boston, it will never come. So to take care of this, we have got something which is called as outer join. I want to get information even about Boston. Okay, now check this. I'll say first, select. I want name, e-name, and I want department. So if I say department number, it will get confused. Are you referring to employees department or departments department? It is confused. So for that reason, to avoid the confusion, we'll say EMP dot. And this one I'll say DPT dot. Why DPT? Because I'll get 10, 20, 30. I want 40 also. For that reason, I gave DPT dot department number. Okay. Now I'll go for normal join from table EMP, comma DPT, comma DPT. Okay. And giving a condition where EMP dot department number is equal to DPT dot department number. This becomes equi-join. So what I'm telling here is, this is not equi-join, this is called as outer. So before equal to open bracket plus close bracket. What does it mean? It means if something is missing in employee table, add it from department table. If something is missing from employee table, add it from department table. That is what it means. That means I'm willing to extract department 40's information also. So that plus indicates not available in EMP, add it from department. That's it. So let us check. So I'll get all, you can see 20, 30, 10, and there is 40 where we have got no one working. No one is working. Now, if the question is like this, display the department where there are no employees, then what will you do? Same query. I want to give one more condition. Here I'll say and emp.ename is null. That's it. Okay, if I give that, it will show me the department where we have got no employees. Okay, let's save this. Was it? Check the out. Okay, so this one is telling that add the information from department if it is not there in employee. Fine, but I am saying display only the record where we have got employee name null. Employee name becomes null when we don't have employees in there. That is what it means. Okay, so this is the query. Question would be like this. Display the department where there are no employees. This is the answer. Okay. Display the department where there are no employees. This is called as what? Outer join. So equi, non-equi, outer. Equi, non-equi, outer. So this is the example. Outer join. Inner join. Inner will be the next. Self join is inner join. Okay. To avoid that confusion only, I'm directly giving you the solution for that. If you know this 4 joins, it means you know all type of joins. Okay. They simply complicate you saying that left outer, right? This is actually left outer join we call. Plus sign given on the right side, right outer join. In place of equal to you say natural, it becomes natural join. Natural join is equi-join. So it is same thing they are telling in different ways. Basic 4 joins, equi, non-equi, outer, self. Done. That's it. Okay. Okay, so copy that. Okay, that's the example. So it is based on master detail relationship. So master is department table and EMP is detail table. So if there is nothing in detail, add it from master. That is what it means. Okay. Self join, inner join is what we are going to see now. For this, we should understand table first. Okay. So I'm giving here select employee number, employee name, NGR from table EMP. This discussion we did it before also yesterday, and the discussion was like this. Smith is reporting to 7902. Okay, 7902 is Ford. Ford is reporting to 7566. And who is 7566? Jones. Jones is reporting to 7839. 7839 is King. King is reporting to no one because he is the president. Okay, second one, Ellen. Ellen is reporting to 7698. Okay, so 7698 is Blake. Blake is reporting to 7839. 7839 is again King. So indirectly saying everyone, whoever is at leading position is reporting to King. Okay, because he is at the topmost level in the organization. Remaining all can be manager, clerk, analyst, different designation, but they are all indirectly reporting or directly reporting to King. Okay, for example, Ellen is reporting to someone, that someone is reporting to someone else, and that someone is reporting to main person, that is president, King. That is how the organization information is there. Okay, now same select statement. I'm just adding one more column called as salary column. Okay. Now let us try to understand. Okay, check this. Anyone reporting to 7566? Check 7566. This person. So Scott is reporting to 7566. His salary is $3,000. Scott is reporting to 7566. 7566 is Jones. He is reporting to someone, but his salary is less than the salary of reporting person. Okay. Let us say you're reporting me, your salary is 3,000 and my salary is 2,975, means $25 less than you. But you're reporting to me. Possible? Is it possible? I'm manager, I'm getting less salary. You're my co-worker, you're getting more salary. Possible or not possible? Possible. You joined long time back, you have experience. I don't have any experience. I joined recently as manager. That's why my salary is 2,975. Your salary is, because you're working from 7 years, your salary is 3,000. Possible. Okay. So if this is the case, the query goes like this. Display all employees who are earning more than their managers. Now how to extract it? Number one, let us see. And say select your name, e-name. Okay, my name, e-name. Your salary, sal. My salary, sal. From table, this table, ELP. Both our salaries and everything is there inside that. So I'm giving this. It shows me repetition of data. This is what I don't want. You are, let's say, co-worker and I'm manager. So to differentiate that, I'm not differentiating that. Am I displaying e-name and same e-name is displayed. Smith, Ellen, Ward, Jones. There is no difference between manager and co-worker. So I'm differentiating in this way. I'll say this name, which I gave first, this is your name. So I'll say C, co-worker. This name is my name. I'll say M, manager's name. This salary is co-worker salary. And this salary is manager's salary. But both of them are in same table, right? So here I'm saying EMP is referred as C, co-worker, and the same EMP table is referred as M for manager. So I'm referring the same table with two different names, which is called as logical name. I'm dividing the table into two, making this as A, this as B. Logically, I'm dividing it. So if I don't give any condition, it returns 14 into 14. 196. 14 into 14. Cartesian product. I don't want Cartesian product. I want to give perfect join. So here what I'm giving, check this. Where I'll say your salary, okay? Or let's say your manager number. I'll say co-workers MGR. Co-workers, let's say I'm 1, you're 2. You're reporting to whom? 1. Yes or no, right? If I refer to the column manager, you'll have 1 there. Your number is, let's say, 101. 101 is reporting to 1. Okay, so if you want to refer to my number, I'll say coworker.mgr should be equal to manager's employee number. Okay, your manager number is 1. Okay, so your manager number should be equal to manager's employee number. That is the condition. That's it. Okay, so I got the salary. This salary is your salary, and this salary is my salary. So if the query is given like display all employees who are earning more than the manager, then the condition goes like this. I'll add one more condition. And co-worker's salary should be greater than manager's salary. That's it. Now check. Your name is going to come. Oh, 1 minute. I did not say that. Here I should say and co-worker's salary should be greater than manager's salary. Close this, save it, update it. Up here, execute it. Your salary 3,000, 2,900. Two of them are there. Ford salary is 3,000. Okay. Scott salary is also 3,000. They are reporting to Jones. Jones salary is less than their salaries. This is called as self-join. Joining table itself. Okay. Let me give you. Joining table itself, which is also called as what? Inner join. With what? With logical division. It's called self-join. Okay, that is. Oh, this is outer join. I did not call. I did this. This is your join and close it. Equi, non-equi, outer self. Join concept is done. Okay. Now, can I join more than one table? If this is the question. Display all employees who are working in Delas, but are grade 2 employees. My question, how many tables are there? Tell me, how many tables are involved? 3. What are they? Display all employees. Employee data will come from EMP table. Okay, who are working in Delas. Delas comes from department table. Grade 2 comes from salary table. How many joins are required? How many joins? 3 tables minus 1, 2 joins. Now, what are the 2 types of joins required? Common table, common column, equi. Equi. That is, EMP department will have equi join. Okay. And salary with sal grade, non-equi join. So I'm combining 2 types of joins and joining 3 tables. How to do it? Let us see. Display employee who are working. So I'll say select. To be clear, EMP dot ename. Some more columns you want. EMP dot salary. EMP dot department number. Something from department table. DEPT dot department name. DEPT dot location. From sal grade dot grade. From table EMP, DEPT, and salary. Where I'll go for equi join. EMP dot department number is equals to DEPT dot department number. And okay. Okay. And I should go for another condition also, that is non-equi join. Okay. So I'll say 1 minute. Sal grade, no, non-equi join. Here I'll say and EMP dot sal is between sal grade dot low sal and sal grade dot high sal. That's it. This is the data that is extracted from 2 tables, equi and non-equi, both I'm using. Paste it, run it. Okay. Salary, sorry, name, salary, department number. This is department name, location. These 2 are coming from department. These 3 are coming from EMP table. This is coming from sal grade table. Give the condition. And sal grade dot grade is equals to 2. Simple. Okay. Think that's all. Here I'll say one more. And as you said, sal grade dot grade is equal to 2. Simple. Okay. Let's close this. Okay. Execute. Any query you tell, I'll give the answer. Any query. Anything which is there in table you want. Okay. Now I want to get department where there are no employees. Can I get? I can. Okay. So that condition what we give here, this one. I don't want this condition because no one is there in that department satisfying with that condition. This condition I want to read. That means I'll get all. 1, 2, 3, everyone I'll get. But I want what? I want to get department where there are no employees. So I'll just give one more condition here. And the condition should be outer join. So did I give outer join here in this? No. So now I'm going to give outer join. I'll say here something like EMP dot. I have to refer to what? EMP and DPT and focus on outer join. So this is equi join. Equi means common columns. So if I just want to go with outer, I'll say plus. If nothing is there in EMP, extracted from department. And I want this. So that join is established. Okay. Now instead of giving it from EMP table, I'll refer this from DPT. Okay. And I want to give one more condition. I'll say and EMP dot ename is null. Okay. Now execute it. No row selected because there are no employees. Okay. no employees working in that particular department. That 2 should be blank and grade should also be blank. Isn't it? Between and high side. Okay, that should work actually. It should give us what? The column, department name and number should appear actually speaking. Okay, so did we give equi-join? Yes. Did we give outer join? Yes. Equi-join is not there because we have did not consider equi. We have considered outer join. Okay, and here we are referring to sal grade, EMP sal between sal grade, low sal, high sal, and EMP dot ename is null. Okay, so let me remove that fifth line, del 5. Okay, here I'm getting all, but department 40 is nowhere appearing. Check. Okay, if department 40 was appearing, then I would have got null and I would have extracted. Okay, so we gave that join, but it is not showing us. Let us do some slight modification. This condition which is there, right? This condition I'm removing it from here, focusing on this type of join, and I add a condition by giving brackets to this. That becomes condition number 1 and condition number 2. Here I say, and condition number 2 is this. Okay, let's see, 40 should come. If you are able to get 40, then it is easy for extracting people where there are no employees. Okay, department where there are no employees. So what happened? I give and 2 times, I think. And this and is not there. Okay. Okay. Is it there? 40 is there? No. Okay, one minute. Here we gave all the columns and grade. Let me add it later. Okay, the sal grade condition I'll give it later. Let us focus on getting 40. If you're able to achieve 40, then it is very easy to get other details. So sal grade, I'm removing it from here. And this. Let's check whether it is showing us 40 or not. Okay. EMP, DPT. What happened here? EMP, EMP, DPT, DPT, DPT location from comma is there, just not right. This comma is not there. Okay, that should give us what is information appear. Now I want to add a grade to this. The same select after displaying employee information, which our manager is also there. Okay, that's fine. So 2 conditions we have given, not this one. This is wrong query. I would say this is the query. Here I want to get sal grade also. So I'll just give you sal grade dot grade. Sal grade dot comma. Okay. I'm going to add up sal grade. Okay. Here giving the condition to fulfill sal grade column. Okay, so here I'll say where EMP dot sal is between sal grade dot low sal and sal grade dot high sal. And this is your second condition. So I'm just placing that in brackets to avoid the confusion. This is also one more condition, putting it in bracket. That becomes 2 different conditions. Okay, sal is between low sal and high sal, and that is the next condition. Okay. So our target is mainly to focus whether we are able to get 40's information or not. If we are able to get 40, is it there 40? No, right? So we are not able to achieve 40 because we are going for the join based on this, and it is extracting grade, skipping that outer join. So if I don't give this, it is extracting this. Okay, we'll see. This is what it is. I should check. I don't have time now, so let me check that and I'll give you the solution. So that is how it will become complicated if they are having more number of tables. So there will be projects where we can find 10 tables. We extract the data from 10 tables. This type of complications will be there. Okay. All right. So I'll just copy this by writing that query, which we are not able to get. And we'll find out the solution for that. This is the query. Copy this and let us paste it here. And I'm just identifying the problem here in this. The problem is, let me just remove it. The problem is this: unable to fetch department 40 details. Okay, query as per query, answer is right, but we want to get department where there are no employees. Okay, so the condition, we have to place the condition in right place so that it will extract. And we are giving AND operator here. I think this is the problem. It should be OR here, then it will come. Okay, both the conditions satisfactory means it is not satisfying that. I should say OR. So if I say OR, then I'll get department 40. Okay, so we'll see that. We'll replace it. Next, we'll see. We'll replace this with AND with OR. That's it. It will come. And we'll check for what two conditions should be satisfied. How can a department will have employees and will not have employees at the same time? Not possible. We should say OR. Okay, fine. So I'll stop here. That's about joins. Just we'll solve this and we'll proceed with the next topic, which would be blocks, named and anonymous. Two types of blocks. That will be in the next session. Okay. So let me just stop recording.